Hello dear students, let's discuss regarding Fick's law, many times asked in environmental engineering. So basically this law is related to diffusion. Okay, so it is known as Fick's law of diffusion. Now there are two laws, Fick's first law and second law. Okay, one by one we will see what is first law, what is second law. So Fick's first law, that is basically related to steady state diffusion. Steady state diffusion. Okay, so what does it state? It states that the molar flux J is proportional to the concentration gradient. So concentration gradient is denoted by dc by dx. dc by dx means change in concentration upon change in distance. Dx is distance. Okay, so the formula will be J is equal to minus d dc by dx. This is the first law of Fick. So Fick's law states that the molar flux J is proportional to the concentration gradient. Now J means diffusion flux. Diffusion flux, that is we can say amount of substance I am writing here, per unit area per unit time. So what will be its unit? Amount of substance, so mole, per unit area means meter raised to minus 2, per unit time means second raised to minus 1. This will be the unit. Same way, what is D? D is your diffusion coefficient. Diffusion coefficient. Even we may call it as diffusivity. Diffusivity. It is basically a proportionality constant. And its unit is meter square per second. Now dc by dx, this is your concentration gradient. So change in concentration upon distance, but dx, it is basically expressed in mole per meter raised to 4. Okay. So now you can see there is minus sign. So what does it indicate? Negative sign indicates that diffusion occurs down the concentration gradient, down the concentration gradient. So that is obvious, anything will move from higher concentration to lower concentration. Okay, so where there is a high concentration, so anything will move from higher to low. Okay, so this is a basic thing, that's why it is negative. So negative sign indicates that diffusion occurs down the concentration gradient. So this is the Fick's first law. Now we will discuss Fick's second law. Fick's second law. Now Fick's second law is related to non-steady state diffusion. Okay, non-steady state, basically both are related to diffusion, but first one is related to steady state diffusion, the second law is related to non-steady state diffusion. Now what is the importance of this law? This law predicts how diffusion causes the concentration to change with respect to time, assuming the diffusion coefficient is constant. Okay, so this is the Fick's second law. Now mathematically we can write curly C by curly T is equal to D curly square C by curly X square. Okay, so now what is curly C by curly T? So basically change in concentration with respect to time, so it is rate of change of concentration with time. D we all know what is D. Then curly square C upon curly X square. So this is spatial concentration. Spatial means along the space. That's why the unit is meter raised to 4. So spatial concentration gradient. So basically it is curvature of concentration profile. Okay, so this is the mathematical form. You can remember it, curly C by curly T is equal to D curly square C upon curly X square. So this is Fick's second law. Now some points just note down, very important, because you should know the relation. First is a higher difference in concentration in concentration, that is high concentration gradient. High concentration it means there is lot of difference between the concentration. uh, so high concentration gradient leads to faster diffusion. Same way, second point is large surface areas allow for higher total flux. And third point which you should remember is smaller distance or smaller distance means thinner membrane thickness, we can term it as thickness also. So if the thickness is less or distance covered is smaller distance or thinner membrane results in faster diffusion. So obviously if the if the membrane is thin, then it will result in faster diffusion. Okay, so these were the two laws. uh, so okay, thank you very much.